Hello, ladies and gentlemen. We are venturing into the world of three-dimensional solids. So it's time to go 3D and talk about some more formulas, things that you would need to use if you're going to try to find the surface area or the volume of something called a prism. Okay, so you've seen these lovely boxes before. How do we find the area? All the surfaces add together. That's what surface area represents, and the volume is the space inside. Okay, so you're going to need your notes, something to write with. We're going to start with a lot of formulas for this unit, so kind of maybe have a highlighter or something so you can highlight those formulas in your notes so you can find them easily. But I would definitely call this a prism page, if you will, in your notes, okay? So first thing we should probably define is a prism is not always just your standard box that you get from an Amazon package or something. Prisms can be named after any type of base that it has. All the sides of the box are rectangles, but sometimes the base is something different. So check this box out. This would be a triangular box, right? Also known as a triangular prism. This beautiful thing right here is a triangle. This beautiful thing right here is a triangle. These are considered the bases of the prism, even though he might not be sitting on it, okay? But the two sides that are different than the other three, the other three along the sides of this box are all rectangles. They are all the same, but the two different sides are considered the bases of the prism. So this is a triangular prism, which means the triangles have to be the base. Triangles equal the base, okay? So notice over here, what's this? Well, this could be a square prism, if you will. If this is a perfect square over here, and then there'd be another one over here that look at, these two are a little different than all the four sides around the outside. So this could be a square prism. Since squares are also just baby rectangles, you could call it a rectangular prism too. But, oh, a square prism. My writing is not too good today. And squares for the base, even though it's not sitting on it, right? The base is not just what it's sitting on. The base is a base, okay? It's what it should be sitting on, but sometimes boxes get knocked over in the back of the truck. It doesn't change the shape of the box when it does that, but it does change its orientation or the way it's showing up on the picture, okay? This beautiful guy, what would we call this? Notice that this is a rectangle, rectangle, rectangle. Those are the sides, but this thing right here is a hexagon. So it's a hexagonal prism. It is a hexagon base, essentially, okay? So the base would be the hexagon. So thinking about what the names of these shapes are called is very important. What would this one be? Pentagonal prism. These beautiful sides are all rectangles. That's what makes it a prism. But the fact that there's two unique sides that are pentagons tells me that this is a pentagonal prism. Okay, the key to understanding what its name is helps us figure out how we're going to find the surface area and volume of it. So we have this idea that there's these bases that are not rectangles typically, unless it's a rectangular prism. And then these are bases. And then around the outside, all the way around, these rectangles are sometimes called the lateral faces. Lateral just means sides. So the sides, the faces of the sides, or the side figures, those are the lateral pieces of the prism, okay? So is there a way that we can find the surface area of a box real fast without finding all of the surfaces and adding them together, which is probably what you did in middle school. You're like, oh, there's a rectangle, let's find that one. Ooh, there's a rectangle, let's find that one. Ooh, there's a rectangle, let's find that one. And the answer to that question is yes. There is a surface area formula, and it looks like this. The surface area, because it's a prism, will always have two bases. So the big B is going to stand for the area of the base. And remember, the base is, think about its name to help us figure out what it's supposed to be, okay? Because sometimes the box get knocked over. The big P in this formula stands for perimeter of the base. Okay, so we need to figure out again that base. That base is really important. That's why we need to figure out its name first. The perimeter of the base. And then the H stands for the height of the box. Now remember, the height of the prism when on its base, because sometimes, again, boxes get knocked over. So this is your surface area formula. This helps you find the surface areas of all those little rectangles added together here real fast without having to do, you know, 6 different rectangles and add them up. So how do you figure out volume? Well, in middle school you probably learned for a rectangular prism, you would just multiply the 3 numbers. Well, that's great for rectangulars, not so good for the rest. The volume formula is the number of cubic units it takes to fill up the solid. So the number of cubes that we would fill inside of a figure. So it's unit cubed all the time. So to find the volume, again, it's about the base. When the base is not a rectangle, we still have to find the area of the base, and we multiply it by the height. So if it's a rectangle, it's no big deal. Length times width and then multiply by the height. But if it's a triangle, we can't use that formula like we did for rectangular prisms, okay? So this is our formula we're going to use, and surface area we're going to use. Let's do a couple. Okay, let's find the surface area and volume of this figure. What is this figure called? What would I name him? Well, I would call him a rectangular prism, right? So that means the base has to be a rectangle. Is it sitting on a rectangle? Yes, right? So this is what I'm going to use as the base. Okay, so there is the base. So I'm going to grab another color here and go B, base. Okay, as long as it's sitting on a rectangle to match his name, we're good. So let's do, ooh, just kidding. Let's do our surface area formula. So surface area equals 2B plus PH. So 2B, B is the area of the base. How do I figure the area of the base? It's a rectangle, so just multiply those 2 numbers, right? 4.89 times 6.15 in my calculator gives me 30.07-ish, right? Plus, what's the P stand for? Perimeter of the base. So this side plus this side plus, what would this side be? 4.89 plus this side, 6.15. So we got to add all those up together to figure out what the perimeter is. Now remember, that number is not the same as the area in most cases. Okay, so you're going to add a bunch of digits. I'm typing in my calculator as fast as I can here. I wanted to make sure I left you enough time to write. That gives me a perimeter of 22.08. And then H stands for the height of the box when it's sitting on its base, and it is. So 4.07 for the height. Okay, so now I go to my calculator, and if you want, you can type this in all at once if you have parentheses on your calculator buttons, okay? But if you don't, we just take 2 times 30.07 times 2 is 60.14 plus, and then we'll take 22.08 times 4.07. Use your cell phone calculator if that's all you got, people. 89.8656, and now add those 2 numbers together. And remember, we rounded a little bit here, so get close. This is about 150. Ooh, nice. There's my digits. Okay. Now, how do we label it? It's an area problem, so centimeters squared. All right, let's do volume. Volume, same deal. Volume equals the area of the base times the height. Well, we already found the area of the base. What was that over here? 30.07? How tall is it? 4.07. Sweet. We just multiply those 2 numbers and we got it. So surface area does take a little bit more time, but when you do it, you have everything you need for volume. So 122.3849. What's my units on volume? Because you're thinking about filling it up with little cubes, it is cubic units. So centimeters cubed, because you're taking a centimeter measurement times a centimeter measurement times a centimeter measurement. Okay? All right, so that's number 1. Let's take a look at a tougher one here, and then we're done. So it says, find the surface area and volume of the triangular prism. Oh, it tells me what the name is. Triangular prism. What does that tell me? It tells me that the base is supposed to be a triangle. So even though it's not sitting on a triangle, it's a box that got knocked over. This is supposed to be the base, okay? So because there's a triangle in the front and the back, you could use either one. Usually I go with the front because it's easier to see. Okay, so let's do surface area. Surface area is 2b plus ph. All right, 2b. B is the triangle. So how do you find the area of the triangle? 1/2 15 times 12, or 15 times 12 divided by 2, right? Because it's a triangle. Triangle formula is needed, okay? So we need to take 15 times 12 and then divide it by 2, and that gives me a base number of 90. So my area of the base is 90, or 90 meters squared, okay? Plus, now I need perimeter of the base, which remember stands for the triangle, not just what it's sitting on. So here we go, perimeter. Let's add up around the triangle. So 15 plus 12 plus, OMG people, I don't know how long this is. Do you know how long this is? What will we do? Oh, you guys, this is a right triangle, is it not? What? Okay. If I need the perimeter, I got to add up all 3 sides, not just 2. So I need to figure that side out. We can do that using Mr. Pythagorean theorem. Okay, let's do it. 12 squared plus 15 squared. Yeah, I know, this stuff never goes away. Did I not say Pythagorean theorem would be the most important things you learned this year? Honestly, I'm pretty sure I did. So when I figure this out, x squared would be 369, square root 369. You can leave it as a square root if you want, but you can also do decimals. 19.209-ish, okay? So that gives me 19.209, or 19.209 here. So if I need to, looky there, I'm getting notifications on my computer from Facebook. If I need to, I can add up all the way around. So let's add up that number plus my 15 plus my 12 for my base. And my total perimeter is 46.209. Okay. And then h, this is the weird part. H is the height. The height if the prism is on the base. So people, if I set the box on this, if I pick it up and put this on the bottom, how tall would it be? Picture it 3-dimensional, then it would be this tall, right? 9.4. So 9.4 is the height. All right, now it's time to calculate. 180 plus, gross decimal, times 9.4, cool. 434.368. Then we're going to add 180 to it. Decimals in my calculator. Surface area is 614.368 meters squared. Woo! There we go. Now remember, you could also find this by finding the area of the triangle, area of the triangle, area of the rectangle, area of the rectangle, area of the rectangle. You would still have to find this in order to find the total surface area. But this formula gives us that in one big calculation. Okay? Let's do volume and then we're done. Volume is area of the base times the height. Now remember, who's the base? The triangle. Did we not figure out what the B was before? Yep, it was a 90. So 90. And then h, again, how tall is this prism if it's on the base? 9.4. The h doesn't change from one to the other. So we just take 90 times 9.4. 846. Done. So 846 units cubed. Ooh, but I know the units, it's meters. So meters cubed. Okay, so definitely the trickiest part is when that's not a rectangle down there. You got to think about that triangle and do 1/2 BH, 1/2 height times base for that triangle, and that'll give you the area of the base of the prism. Okay, all right, thanks people. Kincaid out.